So this question is question 1 from 2015, paper 2, calculator active therefore, time zone 2. In this one, obviously we can see we have a triangle and we have some measurements, and we're just asked to go nuts and really something pretty exciting here. We're going to find AC. So get ready, because it's about to get real. AC, we can see, is this side right here. Now let's talk a little bit about the methods that we have available to us when we're trying to find sides in a triangle. You know that we have law of sines and we have law of cosines. Now in this particular case, what you should notice is that we have an angle of 35 degrees that is opposite a side whose length we know, that's this 10. We also have another angle measure of 80 degrees, which is opposite a side that we would like to know. This is the perfect situation for using the law of sines. This is a textbook case of using law of sines simply because we have a side that is opposite an angle we know, and a side that we want to know that's opposite another angle that we know. So let's go right into it and use law of sines for this problem. So for part A, we can write that the sine of 80 degrees over the side measure that is opposite that side, which is just going to be AC, is going to be equal to another sine, specifically this is 35 degrees, divided by the length of the side that is opposite it, and that is a length of 10. So we can take this, cross multiply. AC is going to be equal to then, what do we got here? 10 sine of 80 degrees divided by sine of 35 degrees. And this is where you pull out that calculator. Please do make sure that your calculator is in degree mode when you do this. This is an easy way not to get that final answer point, just in case they are being a little bit picky on the grading. So when you do this, you get that AC, we'll just put an approximate value of 17.1695. I'll put a ... there because it continues. And this would be a number that you could store in your calculator. Remember, this is a paper 2 question though, so they are expecting you to write your answer to 3 significant figures. So that's going to be 17.2 and leave it there. No more, no fewer. Let's do B now, where it asks us to find the area of this triangle. Let's clean up our diagram just a little bit, because this, you may have forgotten sort of how this works. Let's get that measurement that we just put down here, that 17.1695 ... in for AC. Now you know that the formula for the area of a triangle, you know that it is 1/2 base times the height, you know that, but we sometimes forget that this height is not just any height. It's not just the measure of another side of the triangle. It is the height, the measurement that is perpendicular to the base that we're looking for. So in this particular triangle, what this means is that if we wanted to know the area of this triangle, what we would need to do is, well, we have this base here of 17.1695 and so on and so on, goes on forever. The height that we're talking about is really this right there. It's that part. And if you remember from your right triangle trigonometry, to find that height, if we can get this angle right here, we could find that height, whatever. So this angle, since this is 35 and this is 80 degrees, we can subtract from 180 degrees and get that this angle measures 65 degrees. So this is a 65-degree angle. The height, then, that is this height right here, we can get that height is equal to 10 times sine of 65 degrees. And so just going straight into this formula, we could see that the area of that triangle is 1/2 times the base, which is that 17.1695 and so on number. Multiply that by 10, and then by sine of 65 degrees. Okay, this is not the only way to do this, because we could have done the same thing. We could have used law of sines or law of sines to find this other side of the triangle and done the same thing with the other side. But this method is a pretty straightforward to find the area. Now, we actually discussed when we learned this that this method of finding the height is kind of an extra step that we don't need. We are given an area formula, specifically that area is equal to 1/2 AB sine of C. And the thing to know about this formula is that A and B are the lengths of the sides, side lengths, and C is the angle between those sides. So we can find that area just by saying 1/2. Let's pick two of our sides, and so those two sides, again, we can just use the 17.1695 ... Let's multiply by another length that we have. We have that length of 10, and then let's find the angle that is between those two sides, and that is the 65-degree angle right there. So we could multiply all of this by the sine of 65 degrees, and notice that this is the exact same expression as what we wrote before when we were using some trigonometry to find it. But now we don't actually have to use that trigonometry. We can just use the formula given to us from the formula booklet. But both methods work. Just keep in mind where it comes from and how to use this formula, because it's easy for that not to work for you. So let's not forget, as our last step, to come up with an answer that is correct to 3 significant figures, throwing that in the calculator, and that should be about 77.8. And of course, let's not forget units, always a good idea. Up here, our lengths were given in centimeters, and that means that this area right here, 77.8, would be centimeters squared. And that will do it.